So today we'll be moving into the third unit. So first unit was regarding your over voltage. So what are the over voltage in the power system we have dealt with? So second unit consists of your dielectrics. Okay. So how your dielectric breakdown is possible in different kinds of medium we have seen. Okay. Following from your gaseous, vacuum, liquid, solid, and then lastly it was your composite medium. Okay. So those things we have seen. Now we will be moving to the generation of your high voltage. So how your high voltage is generated. Okay, an interesting chapter. Okay, but over here we will be studying only the theoretical part. I will be putting some YouTube videos. Those YouTube videos will be really amazing and surprising for you. They'll be generating a high voltage in do it yourself manner. So you too can able to try to generate high voltage with respect to that manner. So for that thing, this unit will be your basic. Okay? So this unit will be your basic. So I am audible, right? I am audible. I think so. Yeah. So in this lecture, what we'll be seeing is in this lecture we'll be seeing about only the small part of the theme, that is need for high voltage. Why you need a high voltage? Okay. So what is the need in reality? What is the need for high voltage? Then classification of high voltage will be dealing with how your high voltage are generally classified, followed by half a, that is method of generation. So in this method of generation, here they have given two methods. We'll be discussing about the two methods, and these two methods we have already studied. Okay, so I'll be giving an overview. So one is your half wave and full wave rectifier, and the second method is your voltage doubler circuit. Through these parts, two methods, you can generally generate a high voltage. Okay, we'll be getting into the topic directly. This is your unit on generation of high voltages and current. Okay. First thing is you'll be seeing about your high voltage. Okay. So from the beginning of the this subject itself, we have been talking about high voltage, high voltage, high voltage. So, but you don't know where these kind of high voltages are being used or implemented in the day-to-day life. So here you can see it through this. That is, they'll be mainly going and using your applied physics application. Applied physics. Okay, then so over here the examples so far that are electron microscope. Mainly they'll be making in your laboratories. In your laboratories, they'll be making use of these high voltages. So in the high voltages, one application is your electron microscope. The second one is your X-ray unit. Okay, X-ray units also they'll be using high voltages. Why means at the cathode X-rays you already know the cathode, from the cathode high fast moving electrons will be generated to hit an high atomic element. Okay, so generally for producing such kind of high fast moving electrons, they'll be making use of these high voltages at the cathode. Okay, so third is your electrostatic precipitators in terms of the industries. So mainly to liberate, that is, or separate your carbon monoxide from the outgoing gases. Okay, outgoing waste gases from your industry. Okay, at the chimney point of view, they'll be having these kind of electrostatic precipitators. Okay, so fourth is your particle accelerator in nuclear physics. So this is what your this you can read the article to your God particle. Okay, so at Switzerland they have been using this kind of research. Okay, so from where they have found out your Higgs boson. Okay, or your God particle. So which is responsible for your black hole. Okay, so such kind of thing you need a very high electron to be accelerated. Okay, so such electrons and all, will be energized by very high voltage. Okay. Apart from this, from where in electrical point of view perspective, they'll be going out is they'll be making use in testing of a power apparatus in your what you can say for your high voltage lines. Your insulator has to be designed right. So those insulators will be subjected to these kind of high voltages to see whether it is able to withstand. So sixth is also regarding that only insulating testing of various components in power system. So the seventh one is to simulate over voltage that occur in power system due to light. Okay. So manually you can generate the high voltage. Okay. To check whether it will be affected, the power system equipment will be affected through any kind of lightning. Okay. Apart from this, we'll be moving to your classification of high voltages. Okay. So what are the different forms of high voltage? Just means first one is high DC voltage. High DC voltage. Second is high DC voltage is what you'll be making use in your first four applications. The second one is high AC voltage of power frequency. So I have already told about power frequency. Power frequency is nothing but your frequency which you will be using at your domestic purpose, which is nothing but your 50 hertz. Okay. So next is your high AC voltage of very high frequency. That is apart from your power frequency. Above that, if you're going in, it will be coming under third category. So fourth is your high transient or impulse voltage for very short duration. That is high transient or impulse voltage. We have studied about impulse voltage. Okay. The fifth one is transient voltages of long duration. So this is where the final one. That is the fifth one will be coming in your circuit. Okay. So, but your fourth one will be based upon your lightning phenomena. Okay. So now we can see about the generation of your high DC voltage. Okay, this, first we'll be seeing about each and everything. So in this first you'll be getting with your high DC voltage. How your DC voltage is generated. Okay. So it is first these are the four methods for generating a very high DC voltage. So first one is your half wave and full wave rectifier circuit. So this you know how. Okay, I'll be explaining. The second one is voltage doubler circuit. Okay, third one is your voltage multiplier. So fourth one is electrostatic machine. So all the four also you have already studied. Okay. So the first three you have studied in your power electronics. Okay. The fourth one you have studied in your Vandegraaff you have studied in your 12th standard itself. Okay. So half wave and full wave rectifiers. So I won't be explaining about this thing. So you already know very well. Okay. So rectifiers, what it does, rectifiers usually convert your input AC to a DC. So here we'll be making use of power thyristors or power diodes. Okay, power diodes will be using for generation of very high DC voltage. Okay, so here we won't be making use of normal thyristors or diodes. We'll be making only use of power diodes. Okay, so you already know the difference between power diodes and normal diodes or power transistors or normal transistors. Thyristors, you can just refer to the power electronics if you need. Okay. So you already know this one will be your output will be for one half cycle. This one will be for both the half cycle. Okay. So this is what half wave and full wave rectifier. So here what you have to see is the ripple. So the ripple is what you have to see. The ripple is nothing but your amount of AC quantity in your DC supply. Okay. So the output what you will be getting out is your DC. But ripple is somewhat the unwanted factors. Okay, so the unwanted factor will be your AC quantity. Okay, so that's what your ripple. So your ripple will be large at your half wave. So at your full wave it will be low. So ripple frequency will be your supply frequency in terms of your half wave. But in terms of your full wave, it will be twice the supply frequency. Okay, so this is a basic concept. So regarding this, there is a derivation. That is how you will be deriving your average DC output voltage. So that I won't be dealing. You can just refer to your power electronics. Okay. Otherwise, you can refer to the book. Okay. So next is the voltage doubler circuit. So this also you might have gone through in your oral electronics. So that is over here at the input side, you will be giving out your AC input. Okay, AC supply will be giving. That is, if you are giving a voltage of 5 volt in the sense, at the output side, I'm just saying example, usually you won't be giving a very small magnitude of voltage. At the AC side, what you'll be getting is you'll be getting around 2 times of the voltage. That is 5 voltage if you are giving as an input means you'll be getting an output as 20 voltage. Okay. So generally what happen over here is during the negative half cycle, the potential of C1 that is here there will be making use of two capacitors C1 and C2. So the potential of C1 will be equal to V max, that is the maximum voltage which is charged through your R1. Okay. So generally this will be normally will be of a RC circuit. Okay. So in circuit analysis you might have circuit theory you might have went through. Okay. So here the time constant is tau will be equal to RC. So that's what they have given. But when it is coming to your positive half cycle, what happens? The potential becomes double. So what happened here is the C1 is nothing but the seriously connected capacitor, but your C2 is nothing but your this is what your C2. Your C2 is nothing but your DC-link capacitor is coupled to your load. Okay, so what you need is at the input side you'll be having your maximum voltage, but coming to your output side or at the load side, your DC-link capacitor will be having a twice the times of your maximum voltage. So generally, this value of become will be depending upon your time constant at your load as well as your capacitor. That is DC-link capacitor. So this is another one topology. So that is in this topology, what they'll be doing is they'll be multiply. That is they'll be again using another one voltage doubler. That is, if you are supplying an voltage of V, here they have cascaded two voltage doublers. Okay, so if you are cascading one voltage doubler means you'll be getting an output voltage of 2 volt. Okay, again if you are cascading another one voltage doubler circuit means you'll be getting another one multiplied of into 2, you'll be getting one 4 volt. Okay, so such kind of cascading connections will be in terms of your multiples of 2. Okay, so that's what they'll be giving over here. Okay. So cascading voltage doublers are used when large output voltages are needed without changing the input transformer voltage level. That is your input turns, that is turns will not be in the transformer will not be changed. Okay. So the limitation over here. So what are the disadvantages over here we are seeing? The circuit is somewhat complex in structure. Okay, the circuit is complex in structure, and you need a very large amount of isolating transformer. I have already said about isolating transformer in many of the classes. So isolating transformers are mainly, this is one kind of an isolating transformer. So the isolating transformer are mainly used for your insulation purpose. Okay, so that's one important limitation over here. Okay. So from this, what are the question you can expect over here is you can surely expect the driven expression for output voltage in half wave and full wave rectifier. You can expect this one. Okay, others and all normally they'll be making, they'll be asking in two marks. Okay, this is the only thing they'll be asking in 13 marks. Okay, so with this, this lecture is getting over. Okay, and